So the first question we have for everybody is, who here has heard of CouchDB? Not very long ago, those hands wouldn't be going up. So.
But you guys rock, just for that.
Yeah. And so who's used it a little bit?
Who likes it? It's good. More hands.
Cool. We came to the right place. So I'm Chris Anderson. I'm one of the CouchDB committers. I'm kind of interested in the HTTP, like RESTful side of it. And we're really nice guys, so we can't get to everything in this talk, but come find us later and we'll talk all about CouchDB.
Yeah. My name is Lehnardt. I work also on CouchDB, and I'm more into the, I used to do MySQL and was a big pain. Now I've got this other cool thing working. So that's my background, and we'll talk about cool things you can do with CouchDB.
So, so rather than, because we could give an introductory talk and talk all about, like the basics of CouchDB, but you already know that. So we're going to talk a little bit about what happens once you're already using CouchDB, how you have to think differently writing applications, or how you can think differently if you want. Yeah, we're going to focus on programming applications that live at the edge. There's two features of CouchDB that make this possible. One of them is that applications can be documents, and the other one is that replication is awesome. And when you combine those two, you can get applications that live at the edge of the network.
Okay.
We'll talk all about that.
Good. Yeah, go ahead.
But before we do that, a little bit of CouchDB, and Jan's an expert, so this is our bullet points.
This is the agenda, like the things we talk about on CouchDB. So CouchDB is a document-based database, which is not a relational database, so you don't have any tables, any schema. But you have this thing called documents, which in our case is JSON documents, so you all know JSON, of course. And what you can do, instead of figuring out how to take your data objects that you use in your OO language, might be JavaScript, might be something else, you don't figure out how to split that up in tables and rows, but instead you just store that object. You get back a key. If you want that object back, you give CouchDB the key and get back your object. It's a very simple concept. We've got sort of revisioning control, which is not what Subversion is. That's not real version control, but we use it as a means to expose multi-version concurrency control to the user. So
that whoever saves first wins. You're never going to save over somebody else's work when you're using CouchDB.
Right. The trade-off we are making is that we don't want any locking in CouchDB. So we want to support high levels of concurrency, and a locking system will at some point be busy trying to figure out who's allowed to do what. And in CouchDB, we just don't have any locks, but you need to be the first one to save. And if you come late, you can't save and need to and so on. Blah. The next thing. Oh,
HTTP, right? So you already know the API to CouchDB is HTTP, but there's some cool things about that. One of them is that all the HTTP, like middleware and caches and load balancers, all that just works. So if you've deployed things, into a cluster of HTTP app servers, you can also deploy a large-scale CouchDB installation.
All right. If you've got operations people running your applications, they'll be really happy because they already know how to scale Apache, and they now can take all the infrastructure they have to scale your web front and put it in front of the database. They don't need any special hardware or software to do that. And
we'll talk. One of these bullet points is replication, but we'll go into detail on that. So.
Right. So at this point, we've got a. Oh, sorry.
Yeah, we can go on, and this is all technical and whatever. But hopefully, the big point is that CouchDB is simple. There's just documents. There's not relations. There's not you're not updating parts of documents and hoping that it worked out. It's simple.
So yeah, the scalable thing is scaling's the buzzword of 2008, and I hated it when it started, and I still hate it. So what CouchDB enforces you as the application developer is to make your application in a way that CouchDB will be able to run it on not just a single instance, but on multiple instances. So you can scale up the computing usage of your application, whatever that is. Might be disk, might be memory, might be CPU, but we can just put in more couches to make your application faster and better. The downside is you cannot do everything in CouchDB. So we put you in a sort of a straitjacket that you cannot do things that don't scale, which is still most of the things, because we've got big sites that do scale in other systems, and they do use the same straitjacket. So we just use these in core CouchDB and give you a nice a comfortable place to do scalable applications.
We're a non-relational database for more reasons than just because we're onery. We think there's good reasons to leave that stuff out of your your one shared tier in your application. So distributed, that's the fun part. That's what we're really going to get into. So CouchDB, it uses like 10 megs of RAM when it's under heavy load. It's not, it's not a big thing to install. So you can run it on your smartphone, or what? I mean, that's our hope. And it'll run on the client side, like next to the browser. So you can have applications that come all the way down to the client.
It actually does run on the G1.
Yeah.
See.
Yeah, we got it running on, or someone.
Well, these crazy guys.
Crazy guys got it on the G1. All right, so if you don't believe us, some people have already stepped up to the plate. We won't name any names, but there are people using CouchDB in production, even though it's still alpha software. So
and they're putting real money behind it. I know it. Like I know of a handful of startups that are based around and some project that has CouchDB in its core. So there's real money going into CouchDB already, even though we're kind of not there yet.
But it's because the engineers at the top of these organizations recognize that our design is simple and not too complicated. But that's not what we're here to talk to you about. We're here to talk to you about pure JavaScript applications, because we all love JavaScript.
Yeah.
And there's we'll go through this in sort of crazy order, just because I want to get the big picture across before we get too technical. But what matters about you could write a JavaScript application and host it inside of a Titanium or on your server, or any number of ways. But the cool thing about CouchDB being sort of it's agnostic as to where it's running is that you get these applications and the data as well that you can ship around to the clients. It's I've got a lot to say about this, but I kind of want to spread it out through the course of the talk. The important thing being that the source code travels with the data, with the application. So that means that
think of it in a way that functional programming makes code being data to make code more expressive. CouchDB makes applications being data to make applications more shareable, more independent, and more fun.
So so we hope that we end up making it easier for people to hack on the programs they use on a daily basis. But in order to understand how to build applications in CouchDB, we'll dive a little bit into document modeling. So a basic document is just it's a JavaScript object. It's a JSON, with curly braces, and that lets you put pretty much anything you want into it.
Right. CouchDB reserves the underscore namespace, so every attribute that starts with an underscore is special to CouchDB, and everything else you want to put in there can be whatever. You should be familiar with putting whatever into something, but that's if you come from the relational database. Okay, I'm not a native speaker. I might say stupid things. So I had one talk. I said CouchDB replication goes both ways, and I'm like, ooh, what did I say? Nobody was snickering. I'm like, I didn't get it. Anyway, so in relational databases, you have that fixed schema thing that's totally annoying. If you want to just add one field, you run alter table statement on 16 gigabytes of code, and you're waiting a week until it's done.
But in CouchDB, you need to start storing that that Darth Vader has a sombrero, so you just add the sombrero field to his document.
Right.
And then you've got to do some duck typing in your application so that your view will check for that. But you're already writing if statements hopefully when you're displaying things anyway. So
now go back. Okay, leave the duck. We've got JSON has no type. And if you want to program your objects of some sort of type, and you kind of you want to be able to find out what object is doing what or what document is doing what. So you're quite flexible in applying just tags to documents and then read just these tags, and that's all very flexible. You don't have again not a fixed schema thing. I keep raving about that because I really hate it.
Not having a schema makes it easy to evolve your application over time.
Okay, we should say that having no schema doesn't make migrations go away. So if your data changes, that you need to deal with it, but you don't have to deal with it up front. But you can be a little bit lazy or agile with it.
So switching gears a little bit about from another point of view about the technical aspect of CouchDB, because of the Erlang implementation language. It's designed for super high concurrency. So,
show of hands, who here knows Erlang? Jake, you're not paying attention. That's good. So Erlang was built for telco industries, and that was designed 20 years ago. And they had a couple of interesting problems. They had these big servers that could never be offline. They had these like thousands of calls going on at the same time, and if there were a problem with one of these calls, none of the other could be affected. It's not like you can drop calls if there's a ZAC fault in one of the calls for whatever reason. And a couple of other things. And they solved that with Erlang. And turns out, like today in the web, we have similar problems. We have customers all over the world. There's no like downtime window at night where we can do maintenance. There's so many things going on at the same time. So it's basically the same problem, and Erlang is just the perfect solution for these kinds of problems. So it's a good fit for CouchDB.
Yeah, so what we get specifically in our runtime with it is we get the ability to handle like huge numbers of client socket requests, HTTP requests at the same time. And as the load goes up, the latency will go up a little bit, but the server doesn't just fall over. Your network stack will fall over before CouchDB does.
There was this benchmark in Apache 2 against yours, which is an Erlang clone of Apache 2. And they couldn't get Apache to accept more than 2,000 or 3,000 concurrent connections before it fell over, and they just stopped the benchmark at 85,000 for yours. It's not that there's some magic, so that will take longer. It's a finite computing power. But if you have a huge spike on requests, Erlang will handle that gracefully, whereas other systems are very hard getting that right.
So that's all stuff you don't have to worry about if you're using CouchDB, but it's stuff that makes it fun for us to make CouchDB.
Right.
And another thing that you don't have to worry about when you're using CouchDB is how it does this, but replication is really resilient. You have a data set on this machine, a data set on that machine. You can bring them in sync with a single HTTP request.
So say you have an address book on your phone, on your home computer, on your laptop, on your work computer, and you make changes to one instance, and you want these changes to pop up everywhere else. And there are a couple of projects to do that. MobileMe is one that works pretty well, and other ones that that come up in that space. But they always require you to go through some kind of a vendor through the cloud. And we think it's kind of cool if you could just, my phone is just in the same Wi-Fi that my laptop. Why can't I just not talk without talking to Apple? That would be kind of nice. And CouchDB allows you to do just that, doing multi-node synchronization that works sort of flawlessly without going through any cloud vendor.
Yeah, so ops people really like this because it simplifies a lot of deployment scenarios. So you just have one couch that you've deployed, and the load starts to get kind of high.
So if you like CouchDB, because CouchDB itself is pretty cool, you make an application that runs on CouchDB and it runs on one machine, and you know that there will be problems, things break. That's just a fact. So in that case, you just want to have a second couch that's just there in case that can take over from the other couch.
So this is just a hot failover.
It's just a hot failover or a master-slave thingy that you can set up with MySQL, for example, pretty easily. And if you're the traditional web thing, you have a lot more reads than writes. That's where the next slide comes in. You just make this read cluster that just everybody reads from, and this single master thingy that replicates to the other ones. And you should be familiar with that.
So you just throw your Nginx or whatever in front of that to load balance there, and if this one falls out of the cluster, no big deal, because the load balancer will block the requests.
But that's no different than MySQL replication. That's exactly the use case MySQL replication was designed for.
It's important to note that these arrows are triggered replication. So what that means is that it replicates once and gets everything up to date for each trigger, but you could put the trigger on a cron job. The idea is that we're giving you really simple primitives for moving, for keeping the data in sync.
Right. It's not that you just set up a magic synchronization thing. They are also unidirectional, so you move from one couch to the other and not backwards. And if you want to do that, you just swap the arguments to the replication call from the source and the target database, and this is where this comes in. CouchDB replication, unlike the MySQL master-slave replication, is designed to be a multi-master replication. So any node that runs a CouchDB is a master database as far as CouchDB replication is concerned. And you even can have three masters. You can talk to the MySQL guys and just do two master setups. I've got too much of a write load. I like to do three masters. And no, better don't go there. And in CouchDB, you can the way it's designed, the way you design your application, your own replication, will make sure it will work that way.
Yeah, I mean, there's we'll get to some of the things you have to think about, especially in terms of identity and having the same document on all three nodes. You got to avoid update collisions and whatnot. But that's application level. At the CouchDB level, it just handles that for you, so you can have the same data on all three nodes, pretty easily. And you can get even crazier. There's no reason not to just have everybody replicating with everybody all the time. This is the world that I'm talking about building JavaScript applications for. And that's, this is your computer and that's my computer, and you send me a message, you put something in an envelope for me, and maybe it bounces around a little bit and maybe it gets to me. I mean, it's not the way you'd want to write everything, but it's kind of fun that you can do that without a centralized control point. So to the user, to somebody who's actually using your application, it just sort of looks like they dropped their message into the pond and the ripples are going out.
So yeah, I think we didn't mention peer-to-peer, but that is like a true peer-to-peer setup that you can set up with CouchDB. You just send stuff along and it eventually arrives where it belongs.
Just as long as the two nodes can touch via HTTP. So yeah, maybe one of y'all will be like a scientist and figure out how to get HTTP to go through all the firewalls.
We just buy Skype and they tell us.
So we mentioned document modeling, but it comes up again because applications are documents. So all the things that apply to documents apply to applications.
Oh, we should mention one more feature of documents. So documents are just JSON blobs or JSON documents or objects. But they also can have attachments, just like email can have attachments. So you can just assign or attach arbitrary binary stuff to a document as much as you want. And so you can just put files in there. And files could be, for example, HTML files, CSS files, JavaScript files. And they all get their own URI. So you can point a browser to CouchDB and serve that HTML file from CouchDB into your browser, and your browser will render it because CouchDB will know the correct content type to send.
Yeah, you can even take like a whole set of nested directories, like if you're building static web pages, and just shove it up into a CouchDB document, and everything will work out.
The HTML file then will reference like the JavaScript and CSS resources that then get pulled from CouchDB again, so you get full JavaScript enabled application serving right out of CouchDB without any sort of middleware layer.
So yeah, so when you're doing document-based applications, you want documents to stand alone. You want them to sort of contain their own context. Whereas like in a relational system, what you'd have is one table that pulls out from a million other tables to get the data that you need in order to answer your queries. But with CouchDB, like you want that to be one request. Maybe a couple other requests, but the context is in the document, and so that feeds into having applications be documents, because then you've got this document that is just the whole application right there, and that means that if you replicate it, the application replicates just like a document would.
So practical use case for that's kind of fun. Chris has a blog that's a CouchApp running on jkrsa.net that you can just hit right now if Wi-Fi is still working. I can just replicate from Chris's blog to my CouchDB instance, and now I have Chris's blog software running on my computer. And I really like Chris's blog, but I don't like the green color of the header bar, so I changed that to blue on my CouchDB instance. And then I have my own blog, put my own content in it, publish it to my CouchDB public server, and everybody can read my blog. That's actually Chris' blog, but my content and my colors. And I get a blog for free, which is kind of nice. And then Chris sees, okay, my colors are better, or I did better typography or whatever, and he can pull changes back to his couch and go all crazy. And if you all like the Git model of open source development, that's a lot like it.
Yeah, I mean, I actually do my development sharing in Git still, but for data sharing, like especially public data sets, the ability to replicate it around, and then say you have an application that can graph the number of traffic tickets by square mile radius from your house or whatever. And someone else says, well, that's kind of cool, that square mile radius thing, but I want to see, like some other crime statistic, or, where are they putting in new parks? So you can take the applications and the data and remix them really freely, because everybody's got all the, everything it takes to munge the data as well as to handle the, display in it. So this is my, my little icon for an application. So your document goes into CouchDB, and then it gets unfurled into a beautiful flower of functionality. So look out for that. If you see it again, it's an application. But how? What? It's a database. So how does it run this application? That's what we're going to get into for the next little section here. So there's a special kind of document. The only thing special about it is it lives in this namespace, and CouchDB looks in there for the application.
All right. So a design document, we call these design documents, it's just like a regular document. The only special thing is that the ID of that, or the key of the document starts with _ID / design /. And the other thing is that CouchDB will look for fields in that document. So if it has a field views, and that's what we got there. So views, validations, and my thing went off. So
CouchDB has MapReduce. That's like a nice buzzword that we have, but it actually turns out to be great for transforming and querying JSON documents. The definitions for the MapReduce queries live in the design documents. That was the first thing that got stored in there. And then as we've been adding features, there's document validations, which are run against updates as users save them to make sure they're valid.
So no schema is pretty cool, but at some point you really want to make sure, like if you're storing a blog post, it should have an author's field, a title, and some text body, and the validation functions can they inspect every document that comes in on the write, and then can say, okay, I like a document and I save it, or no, you forget to put in a title or something. Oh,
I forgot to mention, we should just say this, although maybe it's obvious. This is all JavaScript code right here. The MapReduce is written in JavaScript, the validations are written in JavaScript. Most of the functions that you end up seeing people write are less than 5 or 10 lines long. It's really simple. You're just checking for a property on a JSON object. So the API is so simple. We can show you API examples maybe tomorrow at a track B or something. And then rendering HTML is one of the new features, because just having JSON showing up from an API isn't RESTful. That's not enough for a web spider to crawl your site or anything. So we're adding the ability to render HTML, and we'll get into the details of some of the philosophy behind how we do it.
For the first two, the first and the third thing, the render and the MapReduce, if you have a design document and you put in these functions in there, CouchDB will recognize new URIs. So everything in CouchDB is a resource, and these render things and the map and reduce are resources in CouchDB. Now if you define a MapReduce view, CouchDB will recognize that there's a new URI that's /design, your document ID, your view name. And then you can query that view or have that stuff rendered through HTML, through HTTP again. So that's all the same interface.
There's some other stuff that doesn't quite go into the design document, but is still pretty handy. Installed with every copy of CouchDB is jQuery, and then a jQuery CouchDB plugin, which makes it really easy to load documents and save documents and run queries and whatnot.
Thanks, John, for jQuery.
Yeah, it turns out to be pretty handy. So then we of course, is HTTP API. So even just with a static HTML file and the jQuery plugin, you can you can write a full CouchDB application. The example is Futon, which is our built-in admin client, which is all just HTML and AJAX.
Right. We shouldn't mention the AJAX thing. So just pushing out JavaScript and HTML and JavaScript is not that fancy. So we're just pushing static content. But so this is why reinvent the wheel? But in this case, you have your data store is actually a database. So you can use AJAX to talk to CouchDB and do all the document modeling things and query the views and do the validations and all that from your static HTML JavaScript applications. That's pretty neat, I think.
So the kind of applications that, I wrote a little Twitter client which uses their JSONP API. I love JSONP to get the data into the browser, and then you store it into CouchDB, and then you can do you can do a little tag cloud and see what words your friends use too much and stuff based on queries against CouchDB. So application can live in a document, and then we end up with a new kind of replication, which is the same old replication, but it replicates these magic applications instead of just data. That's what I'm passionate about with CouchDB, because I don't know. Here's another survey question: who here in this room got started by hitting view source on an HTML window, and then oh yeah, that's not that hard. So this is a view source for applications. It comes down to your computer. If you can use it, you can get to the source. You can change it, make it better, deploy it to your own CouchDB, which isn't any different from the place where you got it, and generally let the application develop according to what the users want.
Not to get too philosophical, but this is the Wikipedia idea put on steroids. Instead of just editing content that's available for everybody on a central place, you can edit the application that's showing that content in every place you want it to be. So you not only be able to update, you're not only in control of history because you can edit the Wikipedia, but you can also change the display of how that history is being shown to you or others.
Yeah. So the next thing we've got to talk about is just a little bit of the mechanics of how you would write one of these applications, because we've been kind of high level so far. There's a little script and stuff that I am involved in that's called CouchApp, and all it does is take some junk off your file system and stick it into CouchDB in a design document. So
what we mentioned is that you write JavaScript, put it into the JSON document, then CouchDB can figure out how to do views and all this validation crap. You can use Futon to look at your documents, and you've got a text area that shows the JSON or the JavaScript that is in, defines your view. turns out editing JavaScript in the text area field is not the thing we want to do.
Especially because it's like triple escape to JSON by the time you get it to your screen.
Yeah, you really don't want to do that, and yeah, you want to, like, it's code, you want to put code in version control. So what we did is we made a way to push file system hierarchy into a design document. So you have native JavaScript files that you deal with. You can use your editor or IDE, get syntax highlighting, contextual help, and whatever other tools you set up in TextMate or whatever you use. And then just take all that and push that into a format that CouchDB then understands, put it into CouchApp.
So the way this is, a usage example, you'd say CouchApp clone and then a URL, and the URL is the URL of the running application that you may be playing with, and you could just kind of tell by looking at the URL, or maybe you know otherwise that it's running on Couch. So you run CouchApp clone against that application, and it pulls it down to your local file system, and you can play with it, you can change it, you can just look and see how they did it, and
Well, that's the use case I talked about. Like, I see Chris's blog and I can just like pull or clone the entire blog to my file system and see how it works. That's like the view source of
yeah. So CouchApp clone pulls just pulls the code. It doesn't pull the data like the other documents. So it's a good way to share applications around. And then once you have that file structure and you've edited it a little bit, it's pretty simple to push. You just run CouchApp push and type in the name of your local database that you want to see that application running in. And you'll get the application right there after CouchApp gets the files uploaded to the design document. It'll print the URL for you to visit, so you can go see what see if it's running or not. And it's just a file system mapping, so we're hoping to maybe get it hooked up to the Fuse adapter and like otherwise find a really simple ways to make it seamless that you're using this file system mapping. So yeah, that's the mechanics. Now we want to talk a little bit about what it means now you can run these applications and they're bouncing around the edge, and hopefully, if you're lucky, they're running on lots of little smartphones and laptops and who knows what. But that's the end goal. There's a lot of intermediate steps to get there. So there's a few different deployment models, and they differ in how distributed they are. So the first one is a normal server, like it's a server and it has a URL and you go to it and the application is there and you can put it on your bumper sticker.
And this is most likely what all of you are doing.
Yeah. So this is the thing that I got familiar with through PHP and Rails, and there's lots of other ways to do it. But CouchApp will serve that. I mean, a CouchDB design document can be served at a particular location. You can even put some proxy stuff in there. So that if you didn't want people to clone down the source code, it's not that hard to change. And you can also do URL rewriting and whatnot in that deployment. But the downside that we've all probably experienced if our site has had any kind of heavy traffic with being like a normal server is that you are at the middle of it all. All of a sudden you're popular and everyone's coming to you and they want their data and they want it now. And so latency gets really important, and when you have lots of people trying to pull from you, the latency just goes up and up and up, and eventually your site falls over if it's really bad. And it's not good to be unavailable, and it's not good to be slow, especially at the moments when you're getting most popular. So that's a centralized model. We can get a little bit distributed with offline mode. So I mean, you're probably familiar a little bit with offline mode, but maybe you'll.
Like if you run or if you create a CouchDB application, you get the offline mode for free. There's no like things you need to install, no gears programming, no SQL in HTML that some people seem to be happy about. So what you can do, you just run a local copy of your CouchDB. Say like the blog example again. So you're writing home from Jsconf, or you want to say that the CouchDB talk was the most awesomest talk you've ever seen, and you cannot wait. So you fire up your blog on your laptop in flight, and you just type that blog post, post it to the blog on your local CouchDB. When you get home, you just replicate that blog post to your live blog, and it's published. So you could like live interact with your blogging software, but on your local machine, and then whenever you are available again, you can make it available for everybody else.
Well, so another example, like Gmail, right? It's a great service. It makes it so I don't have to worry about setting up SMTP stuff. But if everybody's hitting it all at once, then Google's load is going to spike. Whereas if they were using CouchDB to provide an offline mode, email client, then they don't need to worry about latency, because when you go to hit your replication request to bring yourself up to the remote or to push to the remote, it's not a big deal if it takes 5 seconds for that replication flow to start. And so when you're optimizing for throughput and not latency on the operations side, you can get a lot more throughput. So offline mode can give your users a really snappy experience, but with more predictable, lower load on your servers. So yeah, hopefully we'll see this happening a lot. I mean, we already are, but in the future, people will understand that there's more benefits than just remote availability for offline mode.
And the biggest thing about cloud computing is that it kind of pretends that the network's always available. And like Wi-Fi here is pretty good. Like big props to the ops guys. But when you really need an internet connection, it won't be there, or it won't be too expensive that you like worry about like paying $50 for 10 minutes of internet, or like I don't know, 3G or GSM just goes away, and like you have some other sort of issues. So to have stuff locally that you can work with, and sync, like the replication is pretty resilient again, like against like networking problems. So if it breaks, you can just restart it when network is back.
We've definitely replicated like from Portland to Berlin via his iPhone.
Oh, that was like Wi-Fi in my office went down, so I tethered my like 2G iPhone through my VPN, and then I replicated Damien's CouchDB blog to my machine through that 2G iPhone and across the world. That was pretty amazing.
So then, yeah, offline mode is like replication is good for this, but what we're really here for is the peer-to-peer web. We want the applications to live there so that the kids can hack them. Because like, you know, I want kids to get in trouble for programming too much because they took apart their IM client and put it back together in the way they like it. And so, you know, it's the same thing. The only challenge here is trying to find, you know, a way to tunnel the HTTP between them, but if you can write tools to get around that, or at the worst case, you know, have an ad hoc, you know, public server that you both replicate via, then that can change over time. So yeah, in this case, when you're the application developer, like it's like developing for the desktop. You're not running anything except for maybe, you know, a GitHub repository people can pull down from there, or from your, you know, your starter CouchDB, they can replicate in, and then the application from there is out of your hands and it'll bounce around, and you could drop new changes into the pool, and you know, maybe they'll get picked up or maybe they won't, depending on what your user base is like. But I think that the idea of building web applications in JavaScript and HTML and having them be able to go anywhere and you know, be hacked on by anyone, this is what excites me. Is what got me into CouchDB in the second place. I got into it in the first place for some other stuff, but then I got really fired up when I realized that you could do this. So yeah, that's a little bit about programming at the edge. There's still some other topics we want to cover, but first I want to just quote from the AGPL, which is not a license that I necessarily think we need.
It sucks.
But I do think that it describes what happens when you write applications in this manner. It says public use of a modified version on a publicly accessible server gives the public access to the source code. And what I say is we don't need a license to make that happen, because that's just what happens when your code runs in this kind of CouchApp public manner. So yeah, that's just, you know, make the future. So now back to the application to document programming model. Context is expensive. That's what happens, you know, when these big applications fall down. It's because they're trying to load up like 50 documents and compare them all in one request response cycle, and that's just not where that belongs. You got to decide what goes in the request response cycle and what doesn't. And CouchDB is very conservative about what it lets you put into that cycle, because we're a database and we're not going to let you put something into that cycle that's so that you could, you know, DOS yourself. So yeah, the context stuff has to come outside, but there's a lot you can do without too much context.
Oh, you go ahead.
All right. Well, so rendering documents as HTML is accomplished by a JavaScript function that gets the JSON document as an argument, as well as some of the headers information. So you can switch on the accept header to return HTML or XML or whatever. Our test suite returns a PNG file from one of these functions just to make sure that it works. And it's really simple. You output whatever string you want, and that's what goes to the browser.
So the nice thing is, like, go back one slide. you write this once for your application that when a browser hits it, you serve it HTML. If like an API consumer client hits it with the application JSON accept header, it will get JSON. If a feed reader hits it, you'll get the XML, all from the same source. So you get all that for free from just using the standard CouchDB API. So there's nothing else you will need to provide a feed for your blog or for anything else, and an API.
Well, so it's fun because you can make applications like we've been talking about, but it's also really useful for CouchDB's core mission as a database because you can make it so that you have some legacy API that you need to preserve, but you don't really care about, and you don't want to have to maintain a whole other infrastructure for translating your CouchDB install into this legacy API. So if you implement it in JavaScript, then you can put it up on the couch and it'll just live there forever and you never have to deal with it again.
Like for example, back in the day, CouchDB used to use XML because of JSON, and then we switched to JSON. Everybody was like, "Yay!" Because only some people said like, "Well, we like XML. We still got to use XML," and that's where we give them this. They can transform the JSON transparently into XML. And they can still use that with whatever technology they happen to use.
Yeah, our Spider Monkey interpreter includes the E4X bindings, so you can do native XML processing as well. As I said, like our core mission of being a database, we do this, part of the straitjacket we put you in is that you show one document. You don't load up a document and load up 3 other documents because of it and then change one of them and do something different because of like who the user is. What you do is you just render the HTML or whatever from the document, and that means that there's no side effects. So you can't go like having a GET request so that it screws up your database over time.
That in turn and hidden from the application makes like 3 other GET requests and 5 posts and whatnot that will totally not be able to like sustain a bigger load.
And because there's no side effects, it's cacheable. So that means that you throw like a varnish or whatever in front of CouchDB's, an HTTP cache there, and now things are, it automatically sets up the E tags for you. So when things are the second request, it just comes out of the cache rather than out of CouchDB. So yeah, showing a doc, it's simple. Related, you can list views. So a view in CouchDB, gives you a sorted list of, documents or parts of documents based on whatever key you choose. So it's great for making like a list of all the blog posts by date. But that's in JSON, so if you need that to be in HTML, you can't very well load that whole list up into a JavaScript function and then process it because it could be millions of items long. So what we have is one row at a time processing. So you run once to set up the head of your document, and then after that, your JavaScript function gets called once for each row, and garbage collected afterwards. So you're never gonna.
Or that runs in constant space, so you can kind of blow up memory for just producing an Atom feed out of your blog posts.
Yeah, you can make an Atom feed, hundreds of gigabytes in size, and CouchDB would never hit more than 1 row at a time. So yeah, then it's up to your client to parse it, I guess. So yeah, that's the point of that. It's another straitjacket. You list 1 row at a time, but in return, CouchDB says, well, you do this all you want. You're never going to take down your couch node from it. So sort of the same story with the validations. They're just an update. So an update is the new version of a document, the old version of the document, if it exists, and the user who's making the update. And when you have that information, your JavaScript function either throws an error or it doesn't. And but it doesn't go loading up a bunch of other stuff. It doesn't pull in context to make those decisions.
Right. You're doing the slides, so.
Oh, all right. Yeah. So what do you do? What do you do when you need to make those updates? When you need business logic, when you need stuff that actually needs to look at lots of documents, you've got to do it in sort of outside of the request response cycle. CouchDB has lots of ways that make it easy to subscribe to updates to the database. You can write an OS process, just like a Ruby script or whatever, that gets pinged every time someone does something. You can react to that. We're adding comment hooks. So if you know that eventually at some point someone today is gonna post a document to this URL, you can just hang there on a GET request. And only when that change comes through, then the response comes back to your browser. So you can do instant notifications, and you could also use that from background scripts if you want to start an asynchronous process based on it. So
if you think back on what Chris said, the taking everything that would hurt your application front end is getting taken out of the request response cycle. If you get to like the big ones, Yahoo, Facebook, Flickr, they try that a lot, that they just have to serve static content and everything is pre-processed or is processed asynchronously. That's the way to run big sites. And that's like, again, we only put things in that you can run big sites, but we also make it that it's totally easy to do, that it makes sense to run it on a single, like small site.
So sort of the last point, and this is more something to think about, is how do you manage user identity in a system like this, in the peer-to-peer system? Because you can't ask the server to validate that that they are who they say they are, because you don't know who was the server when that validation was made. So you've got to. I thought about this for a while, and then I thought I was crazy because the only answer I could come up with was by using sort of the
GPG.
The Web of Trust GPG style signed documents, and
we know how well that works.
Yeah, well, the users, I mean, it just hasn't caught on, and that's not like an indictment of the technology, but it's really hard to make the metaphor easy for people. So I'm working on that end, but while I was sitting around thinking I was crazy, I talked to some people who know Lotus Notes really well, and that's what Lotus does. So I guess it's not that crazy. Sort of similar deployment.
And it might not be like cryptographically like super secure. So if you run in your corporation, you get a bunch of messages that is signed with a key, and you know, okay, that guy is Jack, and Jack sent me these messages, and I know all these other messages that I'm now getting are signed with the same key. I'm pretty sure the same person sent the earlier messages, and if I know the earlier messages were coming from Jack, I know the new messages are also from Jack. So this is like, there's the Web of Trust thing is something we take out of there. That's not implicit in the technology, which makes it a lot simpler. So if you really need to be cryptographically sure that there's an identity behind a message, you might need to introduce a little more headache for the user. But for the general user, it might look like Jack. That's Jack. It's all right.
Yeah. So I've been kind of diving in and researching, loading up all the old crypto libraries in JavaScript, and nothing really was quite done. There's some good implementations of the algorithms, but not of the ASCII armored versions of the key pairs and whatnot. So if anybody here knows JavaScript crypto better than I do, which is probably not, I don't know it that well, but I did some research. Let's talk, because I want to make this happen, and I spent 2 weeks researching it. And I think that I mean it's just right there. It's low-hanging fruit, and once we have that, then the peer-to-peer apps thing is going to be totally ready to go. So yeah, we didn't get to do much in the way of actual putting code on the screen because we wanted to give you the feel for CouchDB and what it can do. But I think we're going to do a track B thing tomorrow, hopefully. So if you want to come see code, we'll put that up on the screen and mess up our code examples a lot probably. But yeah, that's oh, and one last thing. We're giving out free hosting for CouchDB. We're maybe, I don't know if.
Well, we've got this project where we try to sell CouchDB for people who are interested in it, and we sort of just set it up so we're not charging for it, and we need people to break it. So please sign up and break it.
Yeah. So so hosting.couch.io, and the invite code for today is stone-horse. So just think of the statue. And find us on Twitter and find us in the hallways. And yeah, thanks for listening.
Thanks.
Oh, well, it's a good question. It's kind of two parts. So the question is, how do you get, with MapReduce, you can build up context, but or how can you build up context? And the other one is, can you use that context in a validation function? So you can't use the context in a validation function. It's just one document, just one update, the old version and the new version. So you're basically validating for well-formedness with a little bit of the user context there to make sure that they're not lying about being the author, if you decide to do that in your function. But you can do join-like queries in MapReduce by collating rows that you want to have next to each other. You can just give them similar keys so it'll collate contiguously. So you can pull out, for instance, a blog post and all of its comments in a single query by setting up your indexes correctly. Well, it just wouldn't. That's an application concern as far as CouchDB looks at it. So yeah, you can have URIs as parts of your.
So there's this quote from Jacob Kaplan-Mauss from the Django team, and he said, like, Django made ASP look out of date because Django was made for the web, and like ASP was pretending the web didn't exist. And he also said, like, CouchDB makes Django looks outdated because CouchDB is not made for the web, it's made of the web. And the web doesn't have, like, there's no integral reference, there's just links. So CouchDB has just links. CouchDB is made of what the web gives us.
Yeah, if you have secret data, you know, if all your data is public, then you can just use your validation function, put CouchDB right there on port 80, and say only let admins update or whatever. But if you have secret data, then you need to use a proxy.
Right. He did that. There's a patch in Jira that we haven't had the chance to look at yet. But like he did it in a weekend, afternoon or something. That was really, really quick that he whipped up his own authentication scheme. So CouchDB, the code base is very, very modular. You can if you happen, you all like the JavaScript, but if you happen to not like the JavaScript, you could all do that in Python or Ruby or PHP or whatever. I wouldn't see why, but you can just very easily swap things out. You can write your own URL extensions. You can write external indexes. We've got a project that integrates with Lucene, so you get full text search. All that is very, very simple to understand.
We should mention too that the code base, the CouchDB Erlang code base, is a great way to learn Erlang because CouchDB has a well-defined HTTP API. As soon as you're comfortable with that API, you look at the code base and you'll start seeing things that you understand and recognize.
There's multiple ways to do backup. One is just having a second node to replicate to do real a host setup or host backup. You can from a live CouchDB instance, you can just run rsync or CP on the database file on disk to your backup target location, and then reload that into a running server again.
So CouchDB's file structure, the file is append only. So if you rsync it, you'll never get an inconsistent file. We don't ever touch anything we've already written.
So there's no complex tools we need to write. You can just use the file system tools to do backup.
So yeah, and then once you rsync it over, then you'd use replication to bring it up to date with any updates that came in while the rsync was running.
It takes about 6 months. Like the first few months, I was like, Damien Katz is the guy behind CouchDB, and was talking to him like, well, CouchDB sucks, it can't even do this. And he's like, think about what you're trying to do here. Like, okay, I'm trying to do this, and this is how it works. And I was like doing nested sets in MySQL. And it can't work. I can't work it out how to do it in a MapReduce view. And like, yeah, take a step back, do it like this, and then use the view like that. And like, yeah, that's totally obvious. That super works, and that's not nearly as complex as what I've been trying to do with a MySQL database. So you need to unlearn a lot of things that you're familiar with from a relation database. It turns out the document metaphor comes from the real world. So everything that we have, like on paper, receipts, all these are documents, and they have the same properties that CouchDB documents have. They are self-contained. Like my business card is a document that doesn't say fax equals null. I just don't have a fax machine. I don't make that explicit.
So specifically, how I was able to start playing with it is I had a Rails app, and what I did is I had my main model, like my user model, and I just load them all and loop through them one at a time. And I was already kind of halfway converting them to JSON for other reasons in my API. So then I just started dumping that JSON to CouchDB, and that gave me enough of a grip to where I could start playing with it. Because that user model is going to pull up stuff from other tables if it needs to make your JSON. So yeah, so just denormalize in your old code and push the documents, or rather normalize, pull it all together, and then push the documents into CouchDB. Oh yeah. Each database is one file.
So there's a couple of things you can do. So if you have like a user application where you don't need cross-reference user data, such as an email, each user gets its own database. So you've got a bunch of files, and like CouchDB was tested with over 1 million databases in a single server, so that's not a problem. And even very big databases, we've got this one project where Chris was doing 90 million documents. Like we get 1,000 documents a second, and then that adds up for a day, and the insert rate after a day of inserting a total of like 86 million documents didn't degrade. So
well, it degraded, but just not hardly at all. I mean, it's order login for inserts, so.
So yeah. And we've got installations that have like around 200 gigabytes of data in a single database, and they work just snappy. It's a bit of a pain to like copy all that data back and forth, and you might not be comfortable with that, but it works.
And there's compaction, so the file is append only, but occasionally, when it starts to fill up your disk, you need to start compaction, which copies only the live data out of the old file into a new file.
Sort of like vacuum in Postgres or SQLite.
Or generational garbage collection.
Right. So the CouchDB API is so simple that the guys at Meebo.com, like the web IAM client folks, they took CouchDB and said, yeah, we need sharding, like we really need it, and they just built it in an Nginx module and a twisted Python client to merge views. And we've got the sharding thing, and we were like, that's pretty cool, can we see some source? And like, we've got to talk to our lawyers about that. I'm like, yeah, do. And a week later or 2 weeks later, they came back, okay, we put it up in Google Code on the Apache 2 license, so everybody can now use that like in production stuff. And it was really, really simple to do just because of our like HTTP API. So yeah, people will teach you not to put binary files into your database because it's a bad idea. And the way you'll be using relational databases is like going through a middleware layer, like swapping from kernel land to user land for 3 times before it hits the HTTP socket that gets sent to the client. That's a really bad idea, unless you like just very lightweight binary stuff that you need the management for. But in CouchDB, it gets streamed from this directly to the user, so it's not a bad idea to put binary stuff into CouchDB. And when I did the binary attachment API that's standalone, I stopped testing it with a 8 gigabyte movie file that I just put in and out. There were no problems.
Yeah, I went gremlin hunting lately, and I was able to make the files a little, it does some bookkeeping in the file, and I was able to pull some of the sparseness out.
So yeah, the programming is about trade-offs, and the trade-off that CouchDB makes is it trades reliability, speed, and whatever else is in CouchDB for disk space, because disk is cheap. So you need, like, if you're in a very tight disk environment, CouchDB might not be the best choice.
But yeah, that's our gambit, because disk is getting free, so.
That is not a concern of CouchDB, but the underlying file system.
Yeah, but it's pretty resilient in terms of as long as you don't get hit by a cosmic array, right, in a B-tree index, and you don't a lot of the data in the file, especially if there's a high update rate and not just new documents, a lot of that data is redundant at a certain point.
The one thing that you need to keep in mind with CouchDB, and that's true for all Erlang applications, they are not optimized for single maximum speed, but for concurrency. So we'll be able to you get the same throughput, but you can host a lot more concurrent users. So the problem with Lidi is that it's single core, so you need to run a lot of Lidis on the multi-core. Erlang is pretty good on the multi-core. What I did benchmarking for a client is put in a varnish in front of CouchDB. And because varnish is a lot faster at HTTP handling and also does a little bit of caching, I got like 20% more reads and writes out of just CouchDB with varnish on the same node. So there are advantages of combining these. If you just want to use Nginx to serve static content, then you don't have a database in the backend. So if you lead the data management part of that, which is pretty neat, then you just use CouchDB. But you can also use a combination to make it like lightning fast.
Or the replication, so that you have a redundant set of data. Yeah, we've got e-tags on all our attachments also. Yeah, I mean, there's no real reason not to. I mean, the whole CouchDB architecture is set up to be stream-based, so we're not going to buffer your 4 gigabyte attachment in RAM and then send it out to the client. So yeah, we may not be as lightning quick as some of those other ones because we're not optimizing for single request latency, but we should be able to, not slow the disk down too much.
But it's still fast enough for like the average user. So instead of like 10 milliseconds, it would take 100 milliseconds, but it's still faster than your eye can see it.
Because you're not trying to get a lot of 10 milliseconds in a row, because you can have 50, 100 millisecond ones at the same time.
But you need to take these numbers with a grain of salt. So CouchDB might be like, this is just pulled out of the air. So CouchDB might be 10 or 100 times slower, but that just like it makes no difference for the user, and you can have a lot more users, and you have the same data throughput.
So yeah, come out to tomorrow. We'll be across the hall, I hope, and we'll show you JavaScript.
And we'll be around all today. Just grab us.
Thanks.
Great, thanks.